In this video, we're going to do a very quick review of trigonometry. Scientists use mathematics to help them describe how the universe works, and trigonometry is really an important branch of mathematics. We'll be using trigonometry throughout this course. So you should have learned about the three trig ratios: sine, cosine, and tan theta. These functions are defined below in terms of the different sides of a right triangle. So if you consider this angle here theta, then the side A, which is directly opposite from this angle, is called the opposite side. I'll just abbreviate that with an OPP. And then the side that is opposite to the right angle here, the 90-degree angle, this is known as the hypotenuse. HYP, I'll abbreviate for the hypotenuse. And the last side that is adjacent to the opposite side is called the adjacent side. Now, if you were to look at this angle here, phi, then this would be considered the opposite angle, and this would be considered the adjacent angle, and this still would remain the hypotenuse. The trig ratio, basically, or these trig functions, are basically ratios of the sides of the right triangle. So sine theta, when you take sine theta, it is basically the length of A divided by the length of side C of this triangle. So it's the opposite over the hypotenuse. If you're doing cosine theta, then it would be the adjacent divided by the hypotenuse. And if you're doing tan theta, it's opposite over adjacent. I seem to remember from my days in math that we used to have this little acronym to help you remember it. I called it SOHCAHTOA. So you can see that you have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent, if you tend to forget that. Remember that the sine theta, cosine theta, and tan theta, all of these trig ratios, are basically going to end up with things without units, because if this was measured, say, in meters, and this was measured in meters, then you would have meters over meters, and you would have a unitless quantity. So all of these three trig ratios are unitless. If you require to find the angle, for example, and you know, for example, two sides of this right triangle, let's say you know side A and side C, and you're trying to find this angle, then you can use the inverse trig ratio. So theta would be equal to the arc sine of A over C. And you should have all been able to done this in your previous math classes, so I'm not going to jump into too much review here. You also should have learned in your geometry days that all three angles in a right triangle will add up, or any triangle as a matter of fact, add up to 180. If you have a right triangle, then these two angles here will always add up to 90 degrees. Furthermore, you should have learned also the Pythagorean Theorem, which says c squared equals a squared plus b squared for a right triangle. And then these two laws are helpful in non-right triangles. So if you have something like an obtuse triangle, or if you have an acute triangle, you can use the law of sines or law of cosines. And if you haven't seen that yet, then go see your math teacher, I would say, and have them help you out. We won't be necessarily using these two laws, but they are helpful. Okay, let's proceed on to example 3. And you should be able to do this. So maybe stop the video, try it on your own, and if you're stuck, then listen to me or continue playing here. So here we have to find angle phi and the lengths x and y. We're given this side 8 centimeters, and we're given the angles 30, 90, and phi. And you may be able to solve this, hopefully, by just using quick geometry rules, because you may notice that this is really a 30, 60, 90 triangle. Well, first of all, I know this angle phi is going to be equal to, really, well, 60 degrees. Well, how do I know that? Well, I know that phi plus 30 plus 90, all three angles in a triangle must add up to 180 degrees. That's called the triangle sum theorem. And so phi must be equal to 60. Or you could also say that 30 degrees plus phi must add up to 90. And so therefore phi must be equal to 60 degrees. Okay, now solving for, say, x or y. Okay, Now, you do not know all three sides. You only know one side, so you can't use Pythagorean Theorem at this point. To figure out x or y, you need to use a trig ratio. Let's say we use this 30-degree angle, and we know that this side is 8, and we call this side as x. So if we look at this 30-degree angle, this side is the opposite side. So 8 centimeters would be considered the opposite side, and x would be considered the adjacent side. And then you think, okay, what trig ratio am I going to use here so that I can figure out this missing variable x? I know the opposite side, I don't know the adjacent, but I do know the angle. So opposite over adjacent. Well, that would be tangent theta. So tan of 30 degrees will be equal to 8 centimeters divided by x. So rearranging for x, you'll have x equals 8 centimeters divided by tan of 30 degrees. And this should give you an answer of 13.85. Now, the most common mistake that people are going to make, probably in this course, is that they'll have their calculator in radian mode when you should be having it in degree mode. We very, very rarely use radian mode in this algebra-based physics course. Okay, so x is equal to 13.85 meters. Okay, if you did not get that answer, then please see me and I'll see what you're doing wrong in your calculator. The next thing is to find y, and there's a lot of different ways you can do it. Now that you know both of these sides, you could use, say, Pythagorean Theorem. 8 squared plus 13.85 squared is equal to y squared. And this will give you y equals 16. Now this, by the way, is probably not the fastest way of doing this. If you're really quick with math, you may have noticed that this is a 30, 60, 90 triangle. And you're given the short leg, which is 8. And how did we get this side? And how did we get that side? Well, really, this side, the hypotenuse, is twice the shorter leg, which is 16. And this leg right here is root 3 times the shorter leg. So it's 8 root 3. And so you may have gotten really quickly to those answers if you had recognized this is a 30, 60, 90 triangle, and you can quickly get those answers without even doing the calculator business. Okay, let's move on to example number 4 down below. So here we have a right triangle, and we're asked to determine the third side x. And what is the angle theta here? So third side x, you can get, if you didn't recognize this triangle quickly, you had to kind of do it the long way, I would use Pythagorean Theorem and say, well, we know that c squared equals a squared plus b squared. And the hypotenuse here is 5. So c is 5, or c squared is 5 squared. A, I guess, we'll label as x, and b we'll label as 3. So we have a squared plus 3 squared. Actually, let's label this as x squared. And solving this algebraically, you're going to get x is equal to 4. But you might also remember an old trick in geometry that when you have a right triangle, you could have, it's called, sometimes, I don't remember what we called it, a magic triangle, 3, 4, 5. Can you think of another one? How about 6, 8, 10? That works, right? That's just double this. There's lots out there. Anyway, let's move on to finding the angle theta. To find the angle theta, there's a lot of ways to do it. Let's say we just knew 3 and 5 and we didn't know side x here. Then you would look at this and say, well, this is the adjacent side to that angle theta, and this is the hypotenuse. So what trig ratio uses the adjacent side and the hypotenuse? And hopefully you're thinking cosine theta. Cosine theta is equal to the adjacent all over the hypotenuse. And so cosine theta will be equal to 3 over 5. Now to find theta, we're going to do the arc cosine, the inverse cosine of 3/5. And this comes out to be 53 degrees, roughly. And one last thing I'd like to add to this already long video is your table of information sheet that is provided on your major test in both sections, the multiple choice and the free response, and during your exam. This sheet is the cover sheet, or the sheet that you're allowed to use on both sections, and it has a bunch of constants listed here. But more importantly, I want to point out that when you do the multiple choice section on the test, for example, you are not allowed to use a calculator. So then you might be thinking, well, how do I solve for like sine of 30 degrees or 45 or whatever it may be? You don't have a calculator to solve for the specific values of that. So in our problems that we'll be designing in the multiple choice, we'll be utilizing problems that have angles in here: 30 degrees, 37, 45, 53, 60, and 90 and 0. So that if you need to find, say, the sine of 30 degrees, it's 1/2, or the sine of 37 is roughly 3/5. So this is like a 3, 4, 5 triangle, the 37 and 53 degree angle. Or if you have to find the sine of, say, 45 degrees, it's √2/2. You've probably learned this in your previous math course. You already probably know of these relationships or these values, but they are available on your quizzes and your test, and so you don't need to memorize it. During quizzes, you're going to be permitted to use your calculator, but during the major test and the final exam, the multiple choice section, you're not going to be permitted to use your calculator, and we will still use trigonometry, but we'll utilize these angles in our problems so that you don't have to memorize what the sine of, say, 53 degrees is. Okay, and that's it for my discussion on trigonometry.